Okay, our next presenter had a long trip from Australia. He is actually from Indonesia, but now living in Melbourne, and he came to have a great presentation. So what do we know about Renaldi? Renaldi Gondosubroto is an accomplished software engineer, instructor, and a developer advocate in the tech community. With over a decade of experience in developing artificial intelligence solutions, he has made significant contributions to numerous companies and communities. Outside of the industry, he is active in the academia community, having his research focused on generative AI and machine learning. Having spoken at over 40 events and conferences, along with having led a chunk of workshops, he has been an international speaker for the past 6 years, sharing his experiences and projects. He's also currently is an AWS subject matter expert for its professional and specialty certifications and holds all 13 AWS certifications along with 20 Microsoft Azure certifications. He aims to build open source solutions which can both help people achieve more value in what they do and promote best practices for fellow developers. When I asked him the questions, what is the key takeaway for the developer's future, he said, look into the best use cases and don't jump on the bandwagon too fast. So please welcome with a warm applause on stage, Renaldi, and his presentation about, one sec, the redefining human AI collaboration, implementing Sentient Support using ChatGPT for DevOps teams.
Thank you. Hello, everyone. Hope you're having a great time at the conference so far. It's been quite a humid weather, I think, pretty much as soon as I hit here. It's quite chilly in Melbourne right now, and pretty much it is at that time of the year. But when I got here, I started pretty much feeling, oh, wow, it's been a while since I had experienced this weather, so I hope everyone's doing great. But yeah, so pretty much I'm here today to give a bit of a presentation talk on redefining human AI collaboration, implementing Sentient Support using ChatGPT for DevOps teams. So really, it's just more of a talk about being able to utilize ChatGPT, generative AI, which is basically, I feel, talked about now for so many organizations, so many use cases that people are currently having for being able to empower DevOps teams. And what I'm going to be showing here is one particular use case that I was able to implement with using ChatGPT. So before we get started, just want to show of hands, who here has already played around with GPT before? All right. More than half the room. That's great. So just before we dive straight into it, I'd just like to reiterate a bit more again. Pretty much a lot of the points have already been mentioned, but yeah, as mentioned before, pretty much my main day-to-day is a software engineer. Some other fun facts, I suppose, that hasn't been mentioned is also that I'm quite active as well within the meetup community, also in particular for Python Melbourne. And I have been, well, actually just recently published my first book as well as an author, which is basically Intro to Things from scratch. But yeah, start writing a couple of more books as well. And yeah, aside from that, I'm also an instructor too. So yeah, aside from that, I really enjoy a lot of things, AWS, open source, testing, virtual reality. So really a lot of different things. And I really like playing around with a lot of different tech and just experimenting with what works. And when Gen AI came about, it's pretty much when I also started experimenting with different use cases, playing around with different algorithm, LLM models, including GPT-4, Bedrock, Gemini. So I've had a bit of a dabble in all the different ones. But what I'm going to really focus on today, however, is looking at GPT, both 3.5 and 4 in particular. So what's the agenda today going to look like? First, I'm going to be giving a bit of an introduction to why we want some kind of sentient support tool to begin with. And after that, I'm going to be giving a bit of the concept and vision of a sentient support tool for CI/CD tools. We're going to be looking a bit into integrating AI into DevOps tools, then measuring the impact of sentient support into seeing how it can impact the organization and impact you as a developer, be able to see the different ethical considerations that is involved within such a tool and how you can build trust, and also what the future sentient support would look like. So let's bit of an introduction about why we want this talk in the first place, why we want to motivate this. Well, firstly, we really have seen day to day the talk at all different organizations, different conferences, all centered on AI. We heard a great deal of this morning in the keynote too about will AI replace developers, which the answer at least was at that time no. And we've seen as well a lot in different conferences that it's been the main message that's being pressed down. If you work with cloud platforms, for instance, like Azure or AWS, I, for instance, went to some of the conferences recently as well, and the whole message, the whole agenda was basically Gen AI. How can we develop Gen AI? How can we work with Gen AI? So it's been a big thing that's really defining the message of this year. And I want to explore this a bit more by really looking more into how it can transform the developer side, starting from a developer and building it that way from the ground up to the organization level, which is when then I can introduce Sentient Support, which is the AI-enhanced help desk for DevOps. Now, what does this mean? You might have read the talk already, you might have not, but I'm going to be introducing this in the next slides as well. And what I really want you to get out of this is be able to look at the concepts, and together we will explore this from that and build up to real-world applications that we can then look into. So let's take a bit of a look into the DevOps evolution as well alongside AI. So we've seen a lot of different evolutions of DevOps, from manual operations to automated workflows. We've seen a lot of automation being done. Someone this morning as well told me too that they live by the motto of if something can be coded, hey, it can probably be automated. Though then again, I was like, okay, maybe we should take a step back because we probably need some human interventions still, regardless. But it's become a very big message these days to a lot of organizations, and it's certainly been a big thing within DevOps automations. You've probably also used a lot of different tools to be able to automate your workflows too, whether it be with Jira, for instance, or other Sneak-based tools, for instance, and remediation actions that can be taken. So a lot of things. And with this as well, AI has become essential to this because we're starting to transition from it being able to be supportive in being able to automate your workflows to it being a central role within how DevOps is automated and how it can be smarter. And this is where we then look into the role of ChatGPT in advancing DevOps methodologies, because it's a very interesting thing. Gen AI has often been thought to mostly been creative, creating new things, creating content, but a lot of the areas that it hasn't really been explored yet is really how it can advance DevOps and be able to empower developers. So what is the concept and vision then of Sentient Support? Well, the vision is to be able to elevate DevOps with the support of AI capabilities. And we can create a tool, essentially, that can empower developers easier this way. And what I really wanted to create originally as part of this was an open source tool which people can build on to be able to be used in a uniform way. And the core functionalities that I wanted at that time was real-time assistance and be able to also solve problems in real time using technologies that we developers use day to day within the DevOps pipeline. And as part of this integration strategy, I then wanted to look into embedding this within different DevOps tools and AI practices. So to give a bit of an example of where this eventually led to, this architecture is pretty much a very high-level diagram of what I wanted the solution to look like and what it eventually ended up being. So as you can see, what I wanted was a way for different DevOps platforms, different containerization tools, and orchestration tools to be able to be combined into one platform so that just with a few lines of instructions instead of code, you can pretty much just combine everything into one platform. So you no longer need a particular knowledge base, or you no longer need to be well versed in, all right, so we need this command to run this. No, we can ask the AI to be able to then do certain actions based on what we are currently instructing it to do. So how this works is that the user is supposed to connect to the code, essentially, and pretty much when the code is run, it can make queries to GPT. Now, these queries pretty much will be based on NLP prompts, which the user will then put through prompts. And this will require a bit of prompt engineering, and this has been pretty much experimented on by me. And when the user prompts things, it then goes into GPT, which processes those prompts accordingly and also suggests relevant changes. For instance, when we talk about code changes, for instance, it provides relevant code. And what it can then do is that for relevant changes, it then saves into a temporary file before then asking you if you want to, for instance, apply those changes or save those changes for you to manually take a look at, which can then be applied to other relevant tools. And in this case scenario, I wanted to look at the most, probably, well, arguably the most important tools of a development pipeline. And in this case scenario, I focused on containerization tools: Docker, Kubernetes, Jenkins. For the purpose of this talk, I'll be going in depth for Docker in particular, although Kubernetes and Jenkins have been implemented as well, at least the functionalities for them. But just to give a bit of a walk through the solution and how it can be implemented, I'll be focusing in depth on Docker because I believe that what's done there can pretty much be replicated as well into the equivalent for Kubernetes and Jenkins. But really, the intention is to be able to ask what you would day to day that you pretty much need to memorize the commands for, memorize the contents for being able to utilize these technologies. So for instance, Docker, how can we just give a few lines of what we want to ask for? For instance, restart my container, please. Optimize my Docker file, trying to make it more efficient. Stop my container. Or for Kubernetes, for instance, can you scale my pods? Can you forward my local port to the pod? Or for Jenkins, for instance, can you build my job, provide my build jobs? That way, we create a centralized solution for all these platforms. And that's the intention of, well, my project pretty much. And for Docker itself, the intention of the role in DevOps itself is to be able to simplify containerization. So what we wanted to be able to do is to be able to automate the management of images, optimize container deployments, and that was what was able to be achieved through being able to integrate it this way. And in this particular case scenario, which I'll be also demonstrating a bit later today too, is looking at from an AI-driven detection perspective. So how can it detect issues within Dockerfile pretty much, and also follow commands to be able to fix issues or be able to optimize the Dockerfile based on your own instructions. For Kubernetes, what I did pretty much was of a similar sort. So what I wanted to do pretty much is focus on predictive enhanced resource scaling and performing automated health checks. And as part of that, what I was able to then do was improve the cluster efficiency with relevant insights from Sentient Support, which is a big thing because at this point in time, one of the biggest things that we always want to be able to achieve is being able to identify issues before they have the chance to occur. So that's one thing that we really need to look more into. And aside from that, we can also look at Jenkins as well. For Jenkins itself, my aim was to be able to assist, have AI-assisted pipeline optimization, and have error diagnosis being put on. And some examples of what this was able to do as well was be able to reduce build failures with preemptive AI analysis. So the issue then becomes, all right, so we already have a vision, we already have a concept. How do we train GPT for DevOps excellence? Well, there's a few things, and just a caveat as well. For those who are not too familiar as well with using GPT models, you always have the option of either using it out of the box, at which you can provide context, which you can provide memory appropriately, or you can fine-tune models. Now, what I show here pretty much is the fine-tuning aspect. It's not achievable by a lot of organizations and individuals just because of how expensive it is, but pretty much you can also provide memory and context this way too, but it's pretty much just an alternate way of being able to do things. Fine-tuning provides more customized data, but at the same time as well, it's pretty expensive. So what I did here was that it's based on memory. So I was able to then pretty much use training sources, provide memory in terms of logs, forums, documentation related to using such tools, and pretty much then achieved a bit of specificity as well through contextual understanding of DevOps terminologies and practices. Luckily, if you've already used GPT before for solving specific issues, for instance, like why is your container not deploying well, maybe you've already asked a GPT. Luckily, it's already able to have some of those knowledge straight out of the box, which is a great thing. But regardless, there are some things that it cannot grasp quickly, such as, for instance, if the API, say, updated, let's say, within the last 1 week, it probably won't be able to know what changed, and that's when you start needing provided knowledge. So let's get straight a bit into more code as well into what I really start implementing. And so the first thing I really wanted to show a bit about is being able to give the model capability to access logs appropriately, because this is also how you're able to then have it look at different issues related to whether it be deployment, creating containers. So this is pretty much one approach of what I did. So I looked at defining specific code for it to get container logs appropriately. So pretty much just accordingly getting it by the client, getting the container logs, and that way we have access to the logs so that when we are prompting the LLM, ChatGPT in this case scenario, to debug a particular issue, we can feed in the specific container logs so that it can take a look at it and appropriately try fixing it based on it. We can then also look at the integration challenge as well, which is really comprised of a few things. Mostly, though, the main hurdle is being able to ensure compatibility across different DevOps environments, just because there's a lot of different tools. Like you were seeing as well, for instance, we have Jenkins, we have Docker, we have Kubernetes. How will this all be integrated, and how can this all work together? And the solution is being able to provide adaptable AI interfaces and custom connectors, which is something I also experimented with as well along the way too. Being able to have the output of one tool interacting with another. And appropriately, that also leads as well to being able to overcome cultural barriers too, which is promoting AI adoption within DevOps teams, just because traditional DevOps teams still have a bit of difficulty in adopting these kinds of tools, and certainly something that has to be more encouraged. And the intent as well is to get community-driven development, which is basically getting the role of the open source community from having more ideation to refinement of the idea accordingly. And of course, as part of this, my vision is to encourage more contributions as well for leveraging community knowledge for continuous improvement, for them to be able to also utilize these kinds of tools and integrate them within their workflows, and appropriately also have community-led enhancements in different kinds of troubleshooting, such as Kubernetes troubleshooting or Docker troubleshooting. And what this can lead to is that we can have a feedback loop, which can have the AI refined with user insights, which really pushes through the importance of user feedback within AI development. And this then leads to different mechanisms, such as being able to collect and implement suggestions for AI refinement. You can probably think of a lot of different use cases for this. For instance, in real-time development, you can pretty much look at how you're able to drive different the AI can drive their improvements through the user saying, OK, maybe I don't want this. I want this input instead. So the AI then tries to find a different way and feeding it with the relevant knowledge, saying, for instance, that, OK, this API has been updated to this. So can you please use this in documentation instead? So this is pretty much how we're able to drive a circular loop for the feedback. And Going further from that, we can start looking at a bit more code again. So what I implemented for the Docker end, for instance, is looking at how we can apply modifications, for instance, in terms of what was done from the Docker as well. So pretty much in this case, you can see that I have a function apply modifications. And what we want to do then is we open a file, we read it in, and we pretty much just assume that the modifications are already made, and we then override the original Docker file if the user then gives the appropriate permission to do so as well. And this is pretty much asked, which I will show in a demo in a bit too. Accordingly, when we look at modifying the Docker file, as I mentioned earlier, we can see that we are also prompting the Docker file appropriately and getting the relevant file path, as you can see over here. So we are appropriately getting the modifications that we have already currently saved temporarily, and pretty much we can just apply it based on the function that we already have. We can then handle requests as well for commands such as restarting the container, for instance, through these kinds of functions. So we can see here that I have a restart container function, and what I can do then is that I can appropriately code it up to basically have the container get the specific ID, stop, and remove the container essentially based on the command that is put through. And of course, this is assuming that the container is run with the same configuration as well, and this can be adjusted as well accordingly with the appropriate statements being printed out too. For querying, for instance, looking at handling the specific queries, you can pretty much get the specific query that is put through as part of the route. And for instance, there's a number of ways that I've experimented with this. One way that I've experimented is hard coding things a bit, which is, for instance, when we try saying restart container. But the other way that I experiment with things as well is also to be able to have GPT take in the prompt, basically, and then read it in, and then say, OK, what does this action correspond to, and then convert it to a hard-coded implementation. So in a way, we're using GPT as some sort of mapper. It's a bit of a roundabout way of doing things, but in my opinion, it is at least a very effective NLP approach, and it's something I'm still ideating as well. But so far, it looks like it's working pretty well. But essentially, that's one way of two ways of being able to do things. In this case, for instance, we're hard coding restart container within the user input. If that's put in, then we are pretty much going to be taking in the whole containers list and pretty much restarting based on the specific ID, with it then asking you which specific container would you like to restart as well. And this can be made intuitive based on the user interface too. And appropriately, it'll then look at uploading the upload folder as well. So this way, it can pretty much handle the query and appropriately perform the action, as you can see here. And as mentioned before, the other approach of looking at being able to read in different user asks is feeding into GPT, which is what I'm doing here, for instance. So pretty much what I want to do here is that I want to be able to load in the memory, which is basically from what the user has already mentioned before, looking at that and looking at the different messages that are put through. So this is pretty much when the user is, when the AI is prompting the user for an affirmative response. For instance, when it's asking, OK, based on what I'm currently doing here, can I make the changes? Do you think that these are good? So this can pretty much be comprised of a few things. It can be a yes, for instance, and can be no, can you further develop this way? Or it can also be maybe you want to apply it yourself. You can also say that way too. But basically, changes will only be applied when you provide the affirmative response. So after that, you can pretty much then just look at the different messages in the message list and look at if the last message provided basically was an affirmative response. And if so, then the message the apply modifications function based on the specific Docker file content, for instance, in this case, for being able to modify the specific file will be executed. And it'll then be returning the change has been applied message. So this way, we can see how it's able to handle different responses and also handle different affirmative responses better too. You can also, for instance, summarize changes too through a summarize Dockerfile function. So we can see over here, for instance, that we can pretty much just have a user query, and accordingly, we mention as well how it can handle specific interactions. So for instance, for our full query, which you can see over here, we are specifically saying, OK, so this is the summary of the Docker file that we have, which is basically showing it. And then after that, it's just pretty much showing what the user input is. And we can then say, all right, so if we provide modifications, include the specific code changes in full Docker file format, and end with, would you like these changes to be applied? So you can see how we are trying to also prompt engineer and structure the responses and handle the different inputs that the user is putting through. And accordingly, from that, we can then predict the conversation, predict the next response, which is basically executing the model with LangChain. So from that, we can then look at the Dockerfile content. We can then save the context appropriately with saving it through memory. And appropriately, as necessary, we also put necessary debug messages too. Now getting a bit into the form element of how this can be structured, we're then looking as well into how we can fetch the necessary Docker chat form. We pretty much add an event listener, which listens to when we are submitting a specific form. And accordingly, we're handling the routes. So for instance, in this case, we're handling the query route, in which case we're handling that route so that when we are querying something, we can pretty much have it sent through and handled appropriately from our functions. And we can do the similar thing as well for uploading the files for the form too. I won't be going too deep into the upload functions, upload files function itself, but it's essentially meant for you to be able to just appropriately select files and handle them and pretty much just have them saved appropriately. So what we can get from this then is that we can start looking into be able to enhance these certain workflows with AI insights. So we can see that it's very important to have these kinds of identification of these kind of issues to prevent code bottlenecks, for instance. And it provides a lot of benefits, including being able to streamline deployments, enhance stream productivity, and it has a lot of impact as well, which you can perform too. For instance, being able to quantify improvements within different development cycles, deployment cycles that you have. Well, that of course comes with a few security considerations, such as there may be security challenges, such as being able to safeguard DevOps pipelines. It's always a challenge to be able to ensure that these kinds of deployment pipelines are secured and ensure that they also maintain, well, integrity. So this is a very important thing to consider too. And some security measures, of course, include how you can ensure secure AI interactions. And there's a few ways really of approaching this. I've played around with a few tools as well. For instance, as I mentioned before, I do a lot of work on AWS. And one of the things I've tried, for instance, is using guardrails, for instance, pretty much to try to prevent certain inputs from being put through, or also by explicitly mentioning, all right, I want to prevent these kinds of inputs from being mentioned altogether. How can I do that? Or how can I prevent these kinds of specific queries? So these are all pretty much a continuing challenge for LLMs, and it certainly will continue to be. And really, it's a matter of just ensuring secure and compliant AI deployments. So being able to ensure that you're abiding by best practices, and security itself really can be another topic, but it's just a very important thing to be able to stay up to date and ensure that you are accordingly sanitizing the inputs, handling different responses appropriately. It's a very important thing. And that leads to also measuring the impact as well. So how do you measure impact in terms of sentient support? There's a few things. KPIs, so seeing, for instance, how resolution times are working, how deployment success rates are currently, and there's a few things that has been already done for this too, that I've tried this too, which is, for instance, in one case, demonstrating how it can be effective as well within real-world settings. So seeing how it can be done as well, how it can be done with a sample production deployment, for instance. And you can also get as well people, DevOps professionals as well, as share experiences with what works, what doesn't. And that's pretty much like how I see Sentient Support can also be measured in terms of impact. And overall, these are still real-world challenges that still need to be overcome, which include having DevOps issues that can be solved with AI assistance, or having different, well, other side issues, including ethical or security issues that have not yet been solved. But really, these kinds of things are important to pretty much be have specific strategies to be implemented for solving these kinds of hurdles. And definitely there's many examples as well for being able to solve these challenges, but it's certainly something that is going to be on a case-by-case basis. And you can also look at Docker optimization with AI itself too, which is basically in the sense of looking at success metrics, such as being able to, for instance, okay, how can I reduce my image sizes? How can I improve container performance? And these are some things that the script I wrote earlier as well was able to do too. So pretty much look at my code, how can I fix this? How can I make this, my Docker file run faster too? How can I reduce my image size? These are pretty much some stuff that is really aimed for being able to be addressed, and it's something that I also look at being able to do too from that. Then that's why it's important to also give access to the logs for the GPT model to also access and look through as well, to be able to evaluate and make a well-reasoned decision. And as part of that, it's important to also look from a Kubernetes perspective too, which is in this sense looking at AI applications within the Kubernetes cluster management. So some stuff that I was able to do for that was be able to look at enhanced load balancing, look at efficient resource allocation better with Kubernetes clustering too, with AI as well, with what I was doing. But in this particular case scenario, it's really important to incorporate the different insights for our users into AI improvements. And similar with Jenkins too, there's a lot of cases as well with looking into improving build processes, and some success include decreasing build failures, optimizing build times. But again, feedback pretty much is important for looking at integration into Jenkins environments. Now, here comes the important part. So I want to give a bit of a demo, particularly on Docker itself, on how this would look like. So pretty much, as you can see here, not too much yet being done on the UX side, because I really wanted more or less of a working use case pretty much for open source use case for this kind of scenario, to show how this would conceptually work and how it would work in the sense of an MVP for both three solutions, particularly for all three Docker, Kubernetes, and Jenkins. So as you can see, we are pretty much just sending it through, sending that message through to be able to optimize Docker file to be more efficient. And as you can see, we have a chat window, what's happening over here. So this format of a chat is able to make it much easier as well for iterative development, iterative feedback, so you can continually tell, okay, I want to improve on this, I want to fix this. So we can see here that we're giving an affirmative solution, so I say, yes, please do, so changes have been applied accordingly. And that way, we see the changes then applied to the Docker file. And as an extra, we can also, for instance, show I want to restart a container over here, and I can just say ask that. So it shows the available containers that can be restarted, and it makes sure that you're restarting the right container because, well, you don't want to accidentally restart a production container, for instance, that you might not want to, so you have to enter it, or you can just copy paste it, similar to the workloads that you get from other confirmation services. And with that, you can see then that container has been restarted successfully. So it's just really a very brief demo case of this. As I mentioned, I wanted to focus more on the Docker element of things because I feel it's much better to deep dive into one than to all three. But what I wanted to really show as well is also just a bit of a discussion as well on ethics and considerations for trust too. So it's important to also develop things well, building the trust in terms of transparency and accountability, making sure that AI decisions are always held accountable and pretty much what you're doing for the user experience can reflect well onto what you're currently doing for them and what you're currently doing if you're as an organization, for instance, like as an organization. And it's important to also, as I mentioned before, balance AI community autonomy with human oversight. Being able to balance that is still a difficult thing, but it's certainly something that a lot of people are looking into. And some future directions pretty much are just improving the UX, for instance, as enhancements, expanding AI capabilities to new DevOps tools and technologies. It's still, as I mentioned before, prototype MVP for open source, not at all like a final solution or anything yet, so it's still continually being developed. And it's my vision for AI and DevOps really is to be able to have really much more support as well, to be able to make strategic contributions and towards key decisions. And some key takeaways, it's a very important transformation from reactive problem solving to proactive innovation, having that pioneering AI-driven help desk, which really is able to elevate DevOps practices through being able to seamlessly integrate within key tools. It's a really great thing. It's not an easy thing by any means to do, but it's really an important thing, especially when we consider the amount of time it can save developers by being able to just format these commands through lines of code, as I showed earlier too in a demo. And open source nature really intends to simplify how community contributions. We want to be able to drastically reduce issue resolution times, optimize workflows, and much more. Emphasize the importance of maintaining ethical considerations, having a future where AI not only supports, but strategically contributes to DevOps, and finally, have more contribution to the development of Sentient Support. So with that, that's really it for me. And yeah, happy to hand it back and answer some questions.
A round of applause, please. OK, so Slido is open, so you can. So we have a few questions already. Let's check. The first one: how can you connect ChatGPT to APIs on private network?
That's a great question. I feel that it's definitely, I feel like a nuanced question. There's a number of ways of doing this, and it also depends on how you define private. Because at least, for instance, I can also define private as pretty much a private network on, for instance, your AWS or Azure environments, for instance. And in that case, you can pretty much just accordingly use endpoints, end-to-end endpoints, and use encryption accordingly based on them to basically have deployed on a private network that way. If you define network, for instance, like private network on the cloud that way, it's definitely possible to. But on the other hand, I feel like most implementations that if you're referring to GPT itself on, for instance, like your own private network, like for instance, if like you're doing like an on-prem development or something like that, like it's going to be a bit different. And I know that there are some variations of GPT that's been implemented recently for private use cases. There's a tool called Private GPT I've been actually playing around with as well. It's also an open source project for private networks, but I haven't done too much work on that. But yeah, as far as I know, at least from a private network perspective, usually it's cloud deployments and the like. And yeah, in that case, you can definitely use encryption or relevant end-to-end solutions for being able to do that.
Okay, next question. With chatbots, we had the issue that at the end, no one knows how to scale the application manually. Do you think AI can push this further?
That's an interesting question. So I feel that at least from being able to scale the application manually, I feel that it certainly is something that can be done. So one way I can see that is with predictive maintenance. So I did a lot of mentioning as well on predictive maintenance, how it can, how I was encouraging as well for more log monitoring. So with being able to scale applications manually, I feel it's one thing that you can use Gen AI or other AI as well to do by looking at the logs, seeing specific thresholds are being exceeded, and pretty much scaling accordingly to that. And I feel that by looking at that, you can automate a solution. And it also depends on the platform you're really on as well. Because I know, for instance, because I do a lot of work on AWS, you also have specific monitoring tools such as CloudWatch and the like to be able to scale appropriately. But if it's, for instance, like from a Gen AI perspective and you want to implement a manual solution, that's also possible too, because you can have it analyze the specific, given that you already established an end-to-end workflow for feeding in the data that you already currently have, for instance, from errors, scaling issues, or thresholds that you don't want to exceed. These are some things that you can feed into it, and accordingly, you can pretty much just have it analyze these and automate the solution as well. So for instance, like, okay, scale up or scale down appropriately based on this. So those are some approaches that I would say would definitely be made possible.
Okay, we have 2 more minutes for questions. ChatGPT produces code which is not running. Would it have sense to give it to a compiler?
Great question. And so, all right, I have a two-step answer for this. Firstly, I acknowledge that it's definitely not always accurate. I've already had my fair share pretty much of non-running code as well in GPT, and that's why as well I mentioned that it's important to still give a yes/no solution still. So when it spews out code for you, make sure you actually still have a human in the loop to monitor the specific code that's being mentioned and look at it carefully pretty much before then using it and applying it. So I feel that you probably could also introduce a compiler to also try to run the code before doing things. That's something of the nature I also tried to implement it. So I did try to implement a running step as well when I tried to integrate this kind of tool in a DCI/CD pipeline and just try to have a step which actually validates the code that actually, firstly, it is valid code, and secondly, that it actually runs well. So yes, I definitely feel that one way you could do it is definitely to have introduced that validation step and compiling step to be able to ensure that the code actually runs well. But I still highly encourage to always try these things with a human in the loop. Because, like I said, and I think it's echoed as well in the main keynote too today, which is, AI can't replace humans. Like, it's meant to support humans, and that's what I'm also meaning to also put through as a message here too. It's meant to do that, and it's meant to support you in your day-to-day, but you still pretty much need to have the human in the loop.
Okay, that's it. I have